Okay, this is Dr. Kruse, Elementary Statistics. We're going to talk about area under a normal curve and how to calculate probabilities based on how far above or below average a score is. So this is called the normal curve. This is just how life kind of pans out. This is how normal things in life are distributed. For example, if I give 100 people a test and I score those tests, and I get an average, well, the average, this is going to be where the average goes, right here at 0. We'll call it mu later. And most people will score really close to the average. For example, 34 people here and 34 people here. Remember, we're talking about 100 people in the room. Percent means out of 100. So pretend there's 100 people in the room, and I give them a test, and I know what the average score is, and I know that 34 people scored just a little bit lower than average and 34 people scored just a little bit higher than average. So if I calculate how far that step is, I'm going to call that a standard deviation. So 34 people scored 1 unit above average and 34 people scored 1 unit below average. This is going to be called mu, all right, the mean, the average. And then the width of this step is going to be called a standard deviation. So I have the average here, and I have 1, 2, 3 standard deviations to the right and just a little bit more. And I have 1, 2, 3 standard deviations to the left and just a little bit more. But if you'll add up all these percents, they add up to 100%. That's all 100 people in the room. So whatever the average test score was, these 68 people, they fell pretty close to the average score. Now, I had 13 and a half people over here that scored pretty low, all right? They're more than 1 standard deviation below average. And I have 13 and a half people here that are pretty high. They're more than 1 standard deviation above average. So what am I up to so far? If I add up 13.5 and 34 and 34 and 13.5, I'm up to 95%. I'm at 95 people out of 100 already, just going from -2 to +2. I already have covered 95 out of the 100 people in the room. That only leaves 5 people, all right? And those 5 people, they're almost unusual, all right? They're almost so high or so low that they're unusual. And some of them we'll even call an outlier because they're so far out here to the right or to the left that they're so unusual, we'll call them an outlier. They're highly, highly unusual. So remember, from -2 to +2, that's going to be 95 out of 100 people in the room. Now the other 5, where do they land? Well, we got a couple here from 2 to 3 standard deviations above average. They scored really, really high on this test that I gave them. And we got about 2 people here, a little more than 2 people here from -2 to -3. That's 2 to 3 standard deviations below what the average score was. Now notice that doesn't cover everybody. That's 99.7 now. If we add 2.35 all the way up to 2.35, that adds up to 99.7%. So that's almost all 100 people. I've got like a part of a percent, think part of a person. I've got a part of a percent here past 3, and I've got a part of a percent here past -3. And these guys are really, outliers are right in here about 2.5 to 3. Those people are outliers. They scored super, super high on the test. That's the people who get, scholarships to college and stuff like that. And these people out here, they're just so unusual. They're like the super geniuses, all right? They're smarter than everybody in the room, and there's not very many of them. That's like the people who score a perfect ACT score and stuff like that. And then we have their, I don't know if I'd call them doppelgangers, but we have their equivalents down here, their mirror images. There's a couple people who scored really, really badly, and then there's one person who scored, worst of all. But all together, it adds up to 100%. So all 100 people in the room are represented under this curve. Most of them, 68 out of the 100, fall within 1 standard deviation of the average score, whatever this test is or measurement that you're taking. All right, so another way to look at it is starting here at the very far left tail. Now this technically goes out to left infinity, but let's just point to this right here and call that the end. From this very far left tail, if I go all the way to the very far right tail, and again, technically this goes out to positive infinity, but we'll just stop right there. So if I go from the left end to the right end, I should have all 100 people. So if I go from the left all the way to the right, that should add up to 100%. That should be all 100 people in the room. I want to kind of reverse that, and let's just look at it the other way, because this is kind of how the Z table works that I'm going to show you in a minute. Let's start at the right end. I'm here at the right tail, and going to the left, let's look at it that way. Let's look at it kind of backwards. From the right side to the far left is all 100%, all 100 people. Now what if I just go from 3? I'm not quite at the far right end here. What if I just go from 3 to the far left? All right, well, I could add these, this plus this plus this and this and this and this and the 2.35. I add those all up, I got 99.85%. That's from 3 to the left. And we're going to look these up in the table later. We're going to look up 3 in the Z table, and it's going to tell us it's pretty close to 99.85% of the people in the room are to the left. All right, somewhere. A bunch of them are here. There's a few here, but they are to the left of 3. They are less than 3 is how we're going to say it here in a minute. Well, what about 2? All right, how many are left of 2? Well, I add up the 0.15 and 2.35 and 13.5 and 34 and 34 and 13.5. So I add up everybody below 2, and that adds up to 97.5%. So out of all 100 people in the room, there's a 97.5% chance that they scored less than 2 standard deviations above average. So they could have scored here or here or here or here or here or even here. All right, that's 97.5 people out of the room will be from 2 to the left. So if Z is less than 2, we're talking about all of these people. That's 97.5 people. That's 97.5%. All right, let's move from 2 to 1. All right, from 1 to the left, that adds up to 84%. I'm adding the 34%. Now here's a quick way of taking a shortcut. 0 splits the curve exactly in half. So at 0, you have 50 people to the left and 50 people to the right. So if I'm going from 1 to the left, I can say, okay, from here to here is 34, and from 0 to the rest of it is another 50. So 34 and 50 is 84%. Or you can do it the long way and just add all of those up. That's going to add up to 84%. So 84 people out of 100 are less than a Z score of 1. All right, what's the probability somebody's less than 0? Find 0 here, and you can do it the long way. Add these 4 numbers up, but it's going to add up to 50%. Why? Because 0 is right in the middle. And 0, mu, the average, the mean, that splits our normal curve into 50-50. I got 50 people over here and 50 people over here. 50 people left and 50 people right. What about -1? How many people are to the left of -1? I need to add 13.5 and 2.35 and 0.15. That adds up to 16 people. There's only 16 people that are lower than or less than -1. There's only 16 people in these 3 areas, this area and this area and this little tiny area right here. That's only 16 people out of 100. Not very many score less than -1. Well, let's go ahead and finish it off. What about -2? All right, -2, there's only 2.5%. That's, 2.5 people. If we could have half a people, 2.5 people live less than -2 or live to the left of -2. That's these 2.35 in this area, and that's that 0.15 in this little tiny area right here. If you add those up, that's 2.5%, or 2.5 people out of 100. And then finally, you have your tiny, tiny little space to the left of -3, and that's not very many people. That's not even a whole percent. That's 0.15%. That's a part of 1%. That's not even a whole person. That's a part of a person. It's technically 15 hundredths of a person. So there's hardly anything there. That's an extreme outlier, but we do have to leave room for that so that everything adds up nicely to 100%. All right, let me show you some notation. So remember I said 0. This is our Z score. We're going to start calling these 0, 1, 2, 3 numbers Z scores now. 0 splits the curve exactly in half. So there's 50 people over here and 50 people over here. 50% are less than 0, 50% are greater than 0, and 50% as a decimal is 0.50. And I just went ahead and went 4 decimal places because that's how it's going to look in the Z table in a minute. We're going to go 4 numbers past the decimal. Here's some notation, all right? So this area right here, less than 0. These are my Z numbers, my 0, 1, 2, 3 numbers. Those are my Z numbers, all right? They're called the standard scores. Now, the probability that I pick a name out of a hat, let's go back to those 100 people in the room, and I put all 100 names in a hat, and I just randomly pick a name out of the hat. What's the probability that I pick out somebody who scored less than average? Well, the probability that I pulled the name out of a hat that scored less than average, 0 is average, is 50%, all right? What's the probability I reach into the hat, and there's 100 people in the hat, and I pull out somebody that scored above average, all right? All of these people scored above average from 0 out to the very far end. Well, the probability is still going to be 50%, but if the numbers aren't nice and easy like this, we have to do a little math. We have to say, well, it's this number taken away from the whole thing, the whole 100%, which is 1 when we're speaking decimal. So I said the probability that somebody scored more than average, all these guys, is calculated or is found by starting with 1, 100%, minus the probability somebody was lower than average, minus this over here. So we're going to take 1, all right, all the way out here is 100%, but I'm going to take away 50%, which leaves me with 50%. So when you're calculating probabilities to the right, when you're calculating probabilities that are greater than, you're going to start with 1 and subtract out the area to the left. Now, why do we do that? Because the area to the left is what the Z table always tells us. All right, so we're just going to have to work that way. We don't have a table that tells us areas to the right. We only have a table that tells us areas to the left. So that's how we're going to have to deal with the problem. If they ask us area to the right, we just got to take 1, the whole thing, and then take away the area to the left, which leaves the area to the right. It'll make more sense in a minute when we look at the table. All right, let's move a little bit to the right here. So I'm going to move 1 standard deviation to the right. So I'm talking about everybody who is from the far left all the way to 1 step above average. I'm talking about all those people added up. All right, so I just drew a line and I shaded this area in. And the probability that I reach into a hat that has all 100 names in it, and I randomly select somebody who scored less than 1 standard deviation above average, any of these people who scored less than or to the left of 1 standard deviation above average, what's the probability that I'll reach in and pick out one of those people? Well, it's 84%. I'll show you how I found it on the Z table. All right, here's our friendly little Z table that I told you was coming. So our Z table tells us the area to the left of whatever Z number you tell it, all right? You just tell it the Z number, and some nice person has already calculated this shaded area for us. So we don't have to do any math or anything. All of these numbers in the table are areas to the left of any Z that you can think of. So I'm starting with a nice easy Z. I said, what was it? I said a Z of 1. So I want the area to the left of Z equals 1. All right, well, here's our Z numbers right here, this first column. That's your Z numbers. Now I want to go to 1, which is actually 1.0. There we go, 1.0. And then there's always another decimal in your Z number. It's always going to be 1 point and then 2 more numbers. So 1.0, and then your third number is up here. See 0 through 9? So let me show you how it works. This is 1.00 right there. That's that 8413 that I wrote on the table. But let me show you the rest of them. This is 1.01. That would be the area to the left of 1.01. This is 1.02. This would be the area to the left of 1.02, and so on. This is 1.03. That's the area to the left of 1.03. And you can see the area is getting slightly larger as you move to the right. We're taking very, very small steps to the right. But every time you take a step further to the right, the area gets bigger and bigger and bigger and bigger. All right, so we looked up 1.00, and that gave us 84%, or 0.8413 exactly. 0.8413 part of the curve is to the left. That's 84.13% of the curve is to the left. Okay, so I've noted that. Now this is real easy to find. You just subtract this from 1, all right? So 1 minus 0.8413 is 0.1587. That's super easy to calculate. The notation's a little more confusing, but as far as looking this up in the table and then calculating that, that's super easy. All right, so the probability that I pick a random person and they scored less than 1 standard deviation above average, that they were in this area here, that probability I looked up in the table, it's about 84.13%. Now, what's the probability that I pull out somebody out of a hat and I pull them out randomly and they scored more than 1 standard deviation above average? The probability that somebody I pulled out of a hat did better than 1 standard deviation above average. Well, like I said, we just take this number and subtract it from 1, and we get that answer right there. So I'm going to take the 84.13 and subtract it from 1. Now here's the notation. It's 1 minus the probability of z being less than 1. This is the probability of z being less than 1. This is the probability of z being more than 1. So if I'm looking for the probability of z being more than 1, I have to take 1 minus the probability that z is less than 1. This part is in the table, and that's how we get that 1587. So looking this up in the table and then calculating that, that's super, super easy. The notation is just a little more confusing. It'll take a little while to get used to. All right, what about the probability that I reach into the hat and I pull out somebody who did worse than 2 standard deviations below average? Whatever the average score was, they did 2 standard deviations worse than that and worse than that. So anybody that scored 2 deviations below average or worse. All right, I looked this up in the table. We'll look it up again here in a second. That's 0.0228. That's about a 2.28% chance. That's not a very good chance at all. Very small chance that somebody scored worse than 2 steps below average, 2 standard deviations below average. And then again, to find the area of the white, you just take the shaded area away from 1 to get your 0.9772. It just needs to add up to 1. That's a real simple calculation. Look this up in the table, and then to find the white area, you just subtract this from 1. Now I have to switch over to our negative side, all right, which just means that we're over here with -1, -2, -3. We're on the left side of 0. So it still shows area to the left. It's just that your z number is going to be negative. So I said -2.0 and then 2.00. So -2.00, that's where that 0.0228 came from. That's the area to the left of -2. And then to find the area to the right, I just subtract that from 1. Okay, here's the notation again, a little confusing. Probability that somebody scored less than -2 is 0.0228. Look it up in the table. Probability that somebody scored more than -2, all of these people over here in the white area, is 1 minus the probability somebody scored less than -2. It's 1 minus the shaded area. All right, let's do the tough one now. What if I ask you about the area in between 2 different z numbers? Well, let me talk you through it first, and then we'll talk about the notation. So I've broken this into 3 areas. I have the shaded area in the middle, and then I have a white area on the left, and I have a white area on the right. So I have 1, 2, 3 different areas, and I need to make sure they add up to 1 to make sure I do my math right. So for this particular example, I said, well, what if z was -2.29? All right, we're going to make this a little more precise now. We're not going to use the easy numbers anymore. We're going to make it a little more precise. So that's negative 2 and a little bit more. So here's 0, here's negative 1, here's negative 2, and then 0.29 is about a quarter of a step more. All right, so it's about there. So I draw a line there. That gives me a white area here. And then what if the other z number is 1.32? Well, that's about 1 1/3 step to the right. So here's 0, there's 1. That's about 1/3 of a step to the right. So I drew a line up and I shaded in between. All right. So the question is, pretend you don't see this right here. The question is, what's the area in between? All right. What's the odds that you pull out somebody who scored in between a negative 2.29 and a 1.32? All right, we're getting pretty precise now. I want to know how many people live in this area. Out of 100 people in the room, there's 100 people under the curve. So out of those 100, how many people scored between this dot and this dot, between negative 2.29 and between 1.32? Well, it's going to turn out to be 0.8956. That's almost 90%. So almost 90 people out of 100 live in this area. All right. But how do you get that number? Well, first of all, the first thing I would do is I would look up this area in the table. Because remember, you can give the table any z number and it will tell you area to the left. So I'm going to look up negative 2.29 in the z table. All right, and here's negative 2.2, and then the third number will be up here. So that's 9, negative 2.29. So negative 2.29 is right there. So 0.0110 people live to the left of negative 2.29. All right, so that's how we found this area. That's easy. Just look this number up in the table. Okay, what do we do now? Well, I mean, there's a couple ways to do it, but the way I do it is I look up the other number in the table. Now think about what that means. When I look up 1.32 in the table, it's going to tell me the area from here all the way to the left tail. All right, it's going to count everybody. Now, I don't really want to count these guys here in the white area, so I need to look up this number. I'm going to look up how many people live left of this number, and that's going to give me a number that's too big, and I'm going to subtract these people out. All right, let me go through it one more time. I'm going to look up this z number, and the table is going to tell me everybody to the left. All right, but I don't want these guys included, so I need to subtract them out. However many people are living right here, I need to subtract them from the total number. All right, let's give that a shot. Let's look up z equals 1.32 in the table. All right, got my z table. There's 1.3, and then the third number's up here, 2, 1.32. So 1.32, that's 0.9066 people live left of that z number, that 1.32. 0.9066 people live left of there. All right, so remember that, 0.9066. Okay, now note that's not what I wrote down here because that's too many people. I take that 0.9066 people that live in that area and I subtract these people in the white area because I don't want them included in the count. So 0.9066 is the area from here all the way to the left tail. Well, that's a little too much. I don't want these people in the white area. So I'm going to take whatever the table tells me for this area, and then I'm going to subtract out the people in the white area, which gives me the 8956. So I'm going to take the 0.9066 minus 0.0110, and I'm left with 0.8956. Okay. All right. Now the only thing left to do is find this area to the right, and that's just what's left over. You know, after you're done figuring out what these two are, that's just what's left over out of 1. So you can do it any way you want to. You can start with 1 and subtract this and subtract that. Or you can remember that from here all the way to the left is 0.9066. So you can just do 1 minus 0.9066 and do it all at once if you like. It doesn't really matter how you do it, but it's going to be 1 minus these guys, whether you do them separately or together. All right, so let's go over the notation now. So here's what we did. Find the area between z equals negative 2.29, this dot, and z equals 1.32, this dot. So first of all, what I do is I look up the area to the left of this guy, the left dot. I start with the left dot because I want to look up how many people live here. So I look up this one, and that's in the table. The probability that somebody is less than negative 2.29 is only 0.0110. So not very many people live here, but that's easy to find. That's in the table. Okay, what do I do next? I look up the area to the, there you go. I look up the area to the left of the right dot. This dot on the right, z equals 1.32. I look up the area to the left of that in the table. So the probability that or probability that somebody scores less than 1.32 is 0.9066. That's like 91 people. Well, I don't want all 91 people, all right? I don't want these people living over here in the left end. So I'm going to take that 91 people and I'm going to subtract out this one person that's living in the left end. So 0.9066 minus the people in the white area. All right, so here's all the notation. It's a little confusing, but you'll get it. The probability that somebody scored between negative 2.29 and 1.32 is the probability that somebody scored less than 1.32, that's the 0.9066, minus the probability that somebody scored less than negative 2.29, that's the 0.0110. And you subtract them and you end up with 0.8956. All right, and all that's left over to do is find the area to the right. Well, the probability that somebody scored more than 1.32 is 1 minus, to the left of 1.32. It's probably the easiest way. So 1 minus the probability somebody scored less than 1.32. That was the 0.9066 number. So 1 minus that gives us 0.0934 people living on the right. All right. All right, let's try one more curve and we'll work a few problems with it. So let's say you're given a word problem or a story problem or whatever. I'm just going to call it a test. Let's say you walked into my class and I gave you a test or a pop quiz, and the average score on the quiz, mu, was 28.9 points. All right, that's just what the average was. I added them all up. I divided by 30 students in the room, whatever, and I came up with an average test score of 28.9. And then I calculated my standard deviation, and it's kind of a give or take of 3.9 points either way. So the class average is 28.9 points on this quiz, give or take 3.9, which means if you add 3.9 or subtract 3.9, that should be most of the class. All right, so let's look at what it looks like. Here's my curve. I start off with my z numbers, my standard scores. That's my 0, 1, 2, 3 numbers, all right? That's 0 plus 1 standard deviation plus another, and then just a hair further past 3. And then going the other way, it's the average minus a standard deviation minus another, and then just a hair further, all right? Those are my z scores. It's always going to be the 0, 1, 2, 3 numbers. 0 is always going to be in the middle. 0 is always going to be your mu, all right, your average. Now, for our story problem, let's apply that to this curve, and these are called x numbers. They're called raw scores. These are called standard scores. Standard means they're going to be the same every time. They're always going to be 0, 1, 2, 3. Raw scores are going to be different every time. It just depends on what the story is, what test you're taking or what you're measuring or whatever. So x is my raw score. All right, they told us the average was 28.9. Well, that goes smack dab in the middle, under 0, 28.9. That was mid-range, mean, middle, mode. In a normal curve, they all go smack dab in the middle. So under 0, we put the class average. Now, if somebody did better than that, we need to add 3.9 points to that. So plus 3.9 puts 32.8 as a pretty good score. That is 1 standard deviation above average. That's pretty good. And if we go the other way, we subtract 3.9 points to get 25. And 25 is a little bit lower than average. The average score was 28.9, but this is still totally normal, all right? You guys remember when we talked about at the beginning of the lesson, between 1 and -1, that's 34 people and 34 people. That's 68 people out of 100 that are within one step of average. That's all the regular people, all right? All the average people. That's 2/3 of the room are going to score from 25 to 32.8. That's totally normal, all right? Now, let's add another standard deviation. Let's add another 3.9. That takes us up to 36.7. And if we go the other way and subtract 3.9, we're down to 21.1. So now this is getting pretty high. That's a pretty high score for this quiz, 36.7. And 21.1 is a pretty darn low score for this quiz because we're kind of edging here toward the really low scores. And see how short this curve is? That means not very many people score this low. Same thing over here. The curve is getting lower and lower and lower. That means not very many people score this high. And let's go ahead and finish it off. Let's add one more standard deviation. So add another 3.9. 40.6 is unusual. It's like I didn't expect anybody to score 40.6 points on this quiz. All right, that would surprise me on this quiz. And going the other way, subtracting 3.9 points, a 17.2 would surprise me just as badly. You know, I would never expect somebody on this quiz to score 17 points. So these are equally surprising. We call these guys outliers. Remember, anytime somebody's out here past about 2.5 steps, that's an unusual score. Over here, this is unusually high. So anything in this neighborhood out here is unusually high. And if I go 2.5 steps the other way, anything in this neighborhood is unusually low. So when we're down here in the 17-point range and lower, those are unusually low. Those are outliers. So 40.6 is unusual. That's an outlier. 17.2, that's unusual. Now 21.1 and 36.7, that's a little bit low and a little bit high, but they're still within the normal range. We don't really hit abnormal until we get out to about 2.5 steps above or below the average. All right, let's finish up here with some conversions. So what if somebody asked you, using that same curve that we just looked at, what if somebody asked you, what's the probability that somebody scored less than 30 points on this quiz? What's the probability that their raw score was less than 30? So just to give you a visual, we're talking about where would 30 be? 30 would be in between 28 and 32. It's somewhere in here. So we're talking about what's the probability somebody scored from here and lower, all right? So I could draw that, I could sketch it and draw the line and shade to the left, but you get the idea. All right, well, to look that up on the table, I can't do anything with the test score numbers, with those raw scores. I can't do anything with that. We need to convert it to a z number. So what I'm really asking is the probability that z is less than what? I need to convert that 30 to a 0, 1, 2, 3 number so I can look it up in the table. So I'm going to come over here and do the scratch work. Here's a nice simple conversion formula where you put in your x number and your average and your standard deviation and do the math, and out pops a z number. So our x number, our raw data, our raw score of 30 points minus the average, 28.9. So it was a little bit above average, 30 minus 28.9. And then I divide it by how big or how wide a step is, 3.9, how big a standard deviation is. So I'm finding the deviation, this person scored above average, divided by how wide a standard deviation is, and it works out to 0.28. All right, so back to our table now. 0.28, that's really close to 0.25, and 0.25 is about a quarter of a step. So we're talking about right about here, and we're speaking z now. So we converted that score of 30 to a score of 0.28 when we're speaking z language. And now that we have a z number of 0.28, now I can look that up in the table and it'll tell me how many people live to the left of that. All right, so you guys look it up in your table, look up 0.28 in your z table, and everything to the left of 0.28, well, that's about 61 people, 0.6103. Or I could say the probability that somebody scored less than 0.28 is about 61%. All right, let's try another one. Let's do the probability that 19 is less than x. Now this is a mean trick that they play on you sometimes because we don't like the x over there. We like the x up here in front. It makes more sense. So just remember, if 3 is less than 5, well then that means 5 is greater than 3. You see how this is opening up toward the 5? That means the 5 is the bigger number. And this is opening up toward the 5. All right? So 3 is less than 5, or you can flip it around and say 5 is greater than 3. Let's do the same thing. 19 is less than x, which means x is greater than 19. It's still opening up toward the x, opening up toward the x. So we like this way better. What's the probability that somebody scored more than 19 points? Well, I need to change that to a z-score, and I'll figure it out. Let's go over here, pop in our numbers. 19 is our raw score, minus 28.9 over 3.9, works out to negative 2.54. So remember we were talking about a score of 19. Here's 17 points, here's 21 points. So 19's in between here somewhere. And we changed it just now to a z-score of, I had to go back and look it up, of negative 2.54. So a score of 19, when I'm speaking x, when I'm speaking raw score, a score of 19 is the same as a z-score of negative 2.54. A z-score of negative 2, and that's almost negative 2.5, a little more than negative 2.5. So let's put it right about there. So if I draw the line up and I look it up in the z-table, remember, it's going to tell me area to the left. But you got to, keep your thinking cap on, because they asked for area to the right. They're asking for this big area over here. They said, what's the probability somebody scored more than 19 points? Well, we changed it to negative 2.54, and we're going to look this up in the table, but the table is going to tell us the probability that somebody scored less than that, and we want more than that, all right? So whatever we look up in the table, we're going to have to subtract from 1. All right, so let's kind of start back over. The probability that somebody scored more than 19 points. Well, we had to change 19 to a z-score, so that's the same thing as the probability that z is greater than negative 254. All right, we did that conversion. Well, the probability that somebody scored more than 2.54 is not something I can look up in the table. I can look up the probability that somebody scored less than 2.54. That's the area to the left, and then subtract it from 1, and that'll give me the area to the right. All right, so the area to the left, that little tiny white area, was only 0.0055, and we had to subtract it from 1 to get the great big area to the right, the probability that z is bigger than. So the probability that somebody scored more than 19 points is like 99 and almost 0.5%. It's almost certain. All right, let's run through a tough one again. So same curve. What's the probability that somebody scored between 32 and 35 points? Now that's raw score. I need to change it to a 0, 1, 2, 3 z number. So this time I got to change 32 to a z number, and I got to change 35 to a z number. Here's your calculations over here. All right, so 32 converts to a z-score of 0.79, and 35 converts to a z-score of 1.56. So I'm going to rewrite this expression. The probability that somebody scores between 32 and 35 points on my quiz is the same thing as the probability that z is between 0.79 and 1.56. All right, so let's take a look here. The probability that somebody scores between 32 and 35, that's 36. So 35 is right about in here, and 32 is just a little bit less than this. So it's over here a little bit. So it's kind of to the left of 1, and then 35 is right up here between 1 and 2. And we came up with 0.79. 0.79 is right about there. That's about, 3/4 of the way over. 0.79 and 1.56. Well, that's really close to 1.5, 1.5. All right. So from 0.79 to 1.56 is what we need to look up in the table. Now you might have to go back to your notes. Remember how I did it. I said, well, I'm going to look up this number on the right, which is going to give me everybody to the left, and then I'm going to look up the number on the left and subtract it away, because I don't want the people in this far left region. I don't want the people from 0.79 to the left. I don't want them included in my count. I just want the people from 0.79 to 1.56. You guys might need to copy this sketch and draw it out and have a look at it. Maybe a visual will help you. So 0.79, draw a line up. 1.56, draw a line up, shade in between. That's what you're looking for. So what I'm going to do is I'm going to start with this number on the right, 1.56. I'm going to look it up in the table. It's going to tell me everybody from there to the left, all the way to the left end. But I don't want the people from 0.79 to the left end. I'm going to subtract that out. So I'm going to look up 0.79's area, and I'm going to subtract that out. So I understand this is a hard question, but you want the probability that z is between 0.79 and 1.56. If you look up less than 0.79, that's the people to the left. So there's a whole bunch of people to the left. 0.7852. All right, there's like 79 people to the left of this number. Those are the ones that I don't want included. Those are the people that I want to subtract out. Now, if I move further to the right, 1.56, and I look it up in the table, they tell me, oh, well, left of this number is like 94 people. All right? I don't want all 94 people. All right? I don't want these people. So I'm going to take the 94 people that live left of 1.56, and I'm going to subtract out the people that live left of 0.79, which leaves me that little tiny sliver in between of 0.1554. All right, last thing we're going to do is convert some z's back to x's. So sometimes they'll ask you to convert the z interval to an x interval. So we're still using the same curve, all right? Average of 28.9, standard deviation of 3.9. Let's say they give you something like this. They say, hey, negative 2.17 is less than z, all right? Well, we could flip it around if we want to, but all I'm really looking to do is change this 0, 1, 2, 3 z number to a raw score on the quiz, all right? So if they're 2 and a little bit more below average, this is 2 steps below average and a little bit more, well, what kind of score was that on the quiz? All right, same formula, but this time we know what z is. It's negative 2.17. We don't know what x is. There's mu, there's sigma. I have to times 3.9 times 3.9. That gets rid of the 3.9 and gives me this equation. And then I plus 28.9 plus 28.9, and that gives me an x score of 20.44. So saying that negative 2.17 is less than z is the same thing as saying 20.44 is less than x. If they scored over 2 standard deviations below average, that means they scored like a 20.44 points on the quiz. Remember, the average score was 28.9. They scored a 20.44. That was pretty low. It was over 2 standard deviations below average. All right, what if they say z is less than 1.28? Well, what does that make the score on the quiz? This says 1 and about a quarter standard deviations above average. So that's pretty good. Positive 1.28. That's about 1 1/4 standard deviations above average. So this test score should be pretty good. Pop in your 1.28, mu, sigma, times 3.9 times 3.9, plus 28.9 plus 28.9. So the score on the test was 33.89. So if z is less than 1.28, that means x is less than 33.89. If they scored something that was 1 1/4 standard deviations above average, that means they scored a 33.89% on the test. Remember average. Average was 28.9, so the average score was 28.9. They scored 33.89. That's pretty good. All right, last one. What about between? All right, let's say the z score was between negative 1.99 and 1.44. Well, what was their scores on the quiz? All right, what scores on the quiz were they between? If z is between these two numbers, then x is between what 2 scores on the quiz? I have to do 2 separate conversions. Here's the negative 199 conversion. So negative 1.99 converts to 2114. And then the 1.44 conversion converts to 34.52. So if z is between negative 1.99 and 1.44, then x is between a test score of 21 and a test score of 34.